Good day, my dear grade 9 learners. How's your self-learning so far? Did the videos that I prepared for module number 4 help you understanding your lessons? I hope so. By the way, we are now on our module number 5, and this is gonna be our third video lesson on Basic Trigonometry Mathematics 9. Once again, I am Teacher Bless, and I'll be your teacher for this video lesson where we are going to review on basic trigonometric ratios, when to use them, and the concept of angles of elevation and depression. Are you ready? Come on! Let's have first our lesson objective. We have here, review the concepts of basic trigonometric ratios and the angles of elevation and depression. Take note, it is very important that you familiarize these concepts because in solving problems involving right triangles, you will be utilizing them. Let's begin with the basic trigonometric ratios. In your Module 1, you learned about the primary trigonometric ratios and the secondary trigonometric ratios. Now, what are the three primary trigonometric ratios? Can you still recall? All right, we have first the sine ratio. Second, we have the cosine ratio. And thirdly, we have the tangent ratio. Now, if you can still recall, when we say sine ratio, that is your opposite over your hypotenuse. And when we say cosine ratio, that is adjacent over your hypotenuse. And when we say tangent ratio, that is opposite over adjacent. So these are the three primary trigonometric ratios. Now, how about the secondary trigonometric ratios? Take note, they are just reciprocal with your primary trigonometric ratios. So we have the first one. We have here cosecant ratio. Next, the secant ratio. And the last one, the cotangent ratio. Now, if you can observe, you cannot find this one in your scientific calculator. So instead of using them, you can use their identities. Remember, your cosecant ratio is just equal to 1 over your sine ratio. And when we say secant ratio, that is just equivalent to 1 over cos ratio. And lastly, cot ratio, that is equivalent to 1 over tangent ratio. Okay, so once again, be familiar with these ratios because you will be utilizing them as we go along with problem solving. Now, there are instances naman that you will be given with an illustration where you are only given with a side or an angle, and then you will be asked to determine what is the appropriate trigonometric ratio for you to solve the missing side or angle. Let's consider this illustration. Now, in your campus, if you can observe, this is your principal's office, and then somewhere here, this is your computer laboratory. And somewhere here, you can find your grade 8 classrooms. Now, if we're going to follow this illustration here, we can make a right triangle, right? So we have here, suppose that the distance from your principal's office to your computer laboratory is 23. And then, this angle here that is formed is 37 degrees. And then you will be asked to determine the distance from your principal's office to your grade 8 classroom. Now, what ratio is applicable for you to solve this missing side here right away? Try to consider our given angle, which is 37 degrees. Now, if we set this angle here to be our angle of reference, what side is 23 and what side is A, which is the distance that we are looking for? Okay, 23 is our opposite side. And A here is our hypotenuse. Opposite and hypotenuse. Therefore, what ratio is applicable? That is, alright, you have here sine ratio. And we know when we say sine ratio, that is your opposite over your hypotenuse. Let's consider this other way of illustration. That's one. You're here still given with 23, the distance from your principal's office to your computer laboratory. The same angle. Take note, we are now asked to find the distance from computer laboratory to your grade 8 classroom. Now, if this angle here is our angle of reference, 37 degrees, what side is 23 and what side is A? 23, opposite. A, adjacent. Therefore, what ratio is applicable? That would be your tangent ratio. So we know tangent ratio, that is opposite over your adjacent. Now let's solve this last illustration. How about if this is the scenario? We're looking for the distance from, okay, the computer laboratory and the grade 8 classroom. Given that you have here the distance from the principal's office to the grade 8 classroom, which is 23, and the angle, which is 37 degrees. What side is A? And what side is 23 if 37 degrees is our angle of reference? A is adjacent side. 23 is our hypotenuse. Therefore, what ratio is applicable? Take note, adjacent and hypotenuse. That would be cosine ratio. So we have here, cos ratio is just equal to adjacent over your hypotenuse. So I hope you now learn how to use or determine what ratio is applicable given the possible angle or side measurement. Let's have a review also on angles of elevation and depression. So it's a windy day and your ground is very wide. So you can do kiting there. So suppose that this is the illustration as you do your kiting. So you have here your kite, and then you're given with this angle here. And accordingly, that's 37 degrees. And then the string here, the string of your kite is 15 meters. And then this angle here from the ground, that is still 37 degrees. Now, which is your angle of elevation, angle of depression, and the segment that represents your line of sight? Let's begin with the angle of elevation. We have this. Is it this angle here, below, or the upper one? That is below. So you have here this angle here, angle of elevation. How about this angle here, the upper angle? This is the angle of depression. Now, how about your line of sight? That is represented by the string of your kite. So this is your line of sight. Now, as you can see here, the measure of your angle of depression is equivalent to the measure of your angle of elevation because these two angles are alternate interior angles. Okay, so that's it for our review on the basic trigonometric ratios and the concept of angles of elevation and depression. Make sure to play, replay, and pause this video for you to understand your lesson better and for you to answer your modules correctly. Goodbye and see you on our next video about problems involving right triangles. Have a great day ahead. Bye-bye!